Look up at the night sky tonight. Now imagine, instead of darkness, you see a glowing arc of rock and dust stretching from horizon to horizon, brighter than a full moon, casting enormous shadows across entire continents. That wasn't a fantasy, that wasn't science fiction. Scientists now believe that is exactly what Earth's sky looked like 466 million years ago. And here's the part nobody talks about. Those rings may have helped trigger one of the deadliest extinction events in the history of life on this planet. This is the story of Earth's lost rings. How they formed, what they did to our world, and why, one day, they may come back. It started with a puzzle that geologists couldn't explain. When scientists mapped ancient asteroid impact craters from roughly 466 million years ago, the Middle Ordovician period, they noticed something deeply strange. Every single one of them was clustered near the equator. Now here's why that's so bizarre. Asteroids don't care about geography. When space rocks rain down on a planet, they hit randomly. Poles, mid-latitudes, tropics, statistically spread across the entire globe. But these weren't random. They were lined up almost perfectly along Earth's equatorial belt. The odds of that happening by chance, astronomers calculated it. The probability is so small it's essentially zero. So if it wasn't random, something organized them. And when researchers dug into the physics, the geology, and the orbital mechanics, the answer they kept arriving at was the same. Earth had rings. To understand how Earth got its rings, you need to understand one of the most violent forces in the solar system, the Roche limit. Every large body in space, planets, moons, stars, has an invisible boundary surrounding it, a gravitational danger zone. Cross inside that boundary and tidal forces tear you apart. It's named after the French astronomer Edouard Roche, who calculated it in 1848. The principle is brutal in its simplicity. If a smaller object gets too close to a much larger one, the gravity pulling on the near side of that object becomes so much stronger than the gravity pulling on the far side that the object literally rips itself apart. 466 million years ago, scientists believe a large asteroid, possibly a fragment from a collision in the asteroid belt, drifted too close to Earth. It crossed the Roche limit, and Earth's gravity shredded it. The resulting debris field didn't fall to Earth immediately. Instead, the pieces spread out into a flat, orbital ring, hugging the planet's equatorial plane, just like Saturn, just like Uranus, just like Neptune. Except Earth's rings were nothing like Saturn's beautiful icy bands. These rings were made of rock, of dust, of pulverized asteroid. They would have appeared darker, more diffuse, but no less spectacular. Depending on where you stood on Earth, you'd see something different. From the equator, a thick glowing band overhead. From the mid-latitudes, a bright arc slicing across the sky at an angle. From the poles, on a clear night, perhaps just a faint, ethereal glow on the horizon. The night sky of ancient Earth looked nothing like ours. The rings weren't just beautiful, they were catastrophic. Rings cast shadows. And Earth's rings, scientists believe, were wide enough and dense enough to block meaningful amounts of sunlight from reaching the planet's surface, particularly in the tropical and equatorial zones. Think about what that means. Less sunlight reaching the surface means less heat. Less heat means the planet cools. And on a geological scale, even a modest cooling effect, sustained over thousands or millions of years, can cascade into something enormous. The Late Ordovician Ice Age began approximately 445 million years ago. Scientists have long puzzled over its trigger. The planet entered a sudden, severe glaciation. Ice caps expanded across what is now Africa. Sea levels dropped dramatically, and ocean chemistry changed. And in the wake of that cooling, one of the 5 worst mass extinctions in Earth's entire history. Approximately 85% of all marine species were wiped out, gone. Entire lineages that had existed for hundreds of millions of years erased now. Researchers are careful to say the rings were likely one factor among several. Volcanism, sea level changes, and shifts in ocean circulation all played roles, but the timing aligns. The cooling effect of a planetary ring system, blocking equatorial sunlight for potentially millions of years, may have been the trigger that pushed an already unstable climate system over the edge. And those ancient craters clustered at the equator, they're the fingerprints, the final evidence. As the rings slowly decayed, which we'll get to in a moment, pieces fell from orbit. And because the rings were aligned with the equator, that's exactly where they hit. The craters aren't a mystery anymore. They're a crime scene. Rings don't last forever. Nothing in orbital mechanics stays still. Scientists estimate Earth's rings persisted for up to 40 million years. But several forces work constantly to destroy them. The moon's gravitational pull, even from 250,000 miles away, would have tugged at the ring material, perturbing orbits, nudging debris off stable paths. Atmospheric drag at the inner edges of the rings would have slowly bled momentum from smaller particles, pulling them down into increasingly lower orbits. Solar radiation, the constant pressure of photons streaming from the sun, would have gently but relentlessly pushed lighter particles off course. And as debris fell back toward Earth, meteor showers, constant, sustained meteor showers lighting up ancient skies, far more intense than anything we experience today. Over millions of years, the rings thinned, faded, until one day the last particles fell to Earth, and the sky, for the first time in 40 million years, was clear again. Earth had lost its rings, and the planet it left behind was changed forever. Here's a question that's hard to shake once you've learned all of this. What would life be like if Earth still had those rings today? The answer, honestly, harder, much harder. Our entire modern civilization depends on satellites, GPS, communications, weather forecasting, financial systems, military operations. Right now, there are roughly 9,000 active satellites orbiting Earth. In a ring-bearing Earth, most of those satellites couldn't exist. The debris field, millions of particles at orbital velocities, would make certain orbital zones essentially impassable. A satellite attempting to cross through a debris ring would be destroyed. Launch trajectories would need to avoid vast swaths of near-Earth space entirely. GPS accuracy would degrade or disappear in affected zones. Radio signals would experience interference and scattering from the ring particles. The Hubble Space Telescope, the ISS, deep space launches, all of it would be more dangerous, more expensive, or outright impossible. And the climate effects wouldn't be subtle. Depending on the density of the rings, equatorial regions could experience significantly reduced sunlight. The tropics, currently Earth's most biodiverse and agriculturally productive regions, could see meaningful cooling. But here's the other side of that coin. The rings would be extraordinary. From temperate latitudes, they'd be one of the most magnificent sights the human eye has ever seen. Brighter than the moon in some configurations, casting soft ring shadows across the ground. Every culture on Earth would have built mythology, religion, and art around them. Human history, driven by navigation, climate, and the night sky, would be almost unrecognizably different. Here's the thing about planetary rings that most people don't fully appreciate. They're not rare. They're not exotic. Saturn, Jupiter, Uranus, Neptune, every gas giant in our solar system has them. Rings are a natural consequence of gravity, debris, and orbital mechanics. Earth has had them before, and Earth may have them again. The moon is slowly migrating away from Earth, about 3.8 centimeters per year. In the very distant future, tidal forces between Earth and Moon will behave differently. Meanwhile, the asteroid belt remains a crowded, dynamic place. Future large impactors, or large objects passing at just the right distance, could once again cross the Roche limit. Earth is not a static, finished world. It is dynamic, active, capable of radical transformation across geological timescales. The ancient rings that once glowed above a lifeless, shallow ocean are gone, leaving behind only craters, fossils, and the faintest geological whispers of what once was. But they were real. They shaped our world. They may have shaped the very conditions that eventually led to us. And somewhere in the deep future, perhaps long after humanity is gone, or perhaps as witness to something we haven't yet imagined, Earth may once again wear its rings. The sky is never really finished. If this story genuinely surprised you, if you didn't know Earth once had rings, and that those rings may have driven a mass extinction, then you now know something most people never will. Share that. Send this video to someone who loves space, science, or Earth history. The comment section is open. I want to know, does it change how you think about Earth, knowing it's been this radically different before? Drop your answer below. If you're not subscribed yet, we cover exactly this kind of story. Not just what we know, but the mysteries hiding underneath what we think we know. The subscribe button is right there, and the next video is already queued up for you. I'll see you in the next one.